Dispersion. Today our topic is dispersion. It badly impacts dwdm channels. It reduces the effective bandwidth and escalates the error due to increasing inter-symbol interference. It is critical and it limits the quality of signal and transmission in dwdm. Chromatic dispersion is one of the type of dispersion. It causes pulse broadening and generates errors. Dispersion is the time domain spreading or broadening of the transmission signal light pulses as they travel through the fiber. We use G.652 fiber for DWDM. This is dispersion shifted fiber with minimum dispersion point at 1550 nanometer. 10 km DC module has less than 2.4 dB loss and 20 km DC module has less than 2.8 dB loss. In this way, 100 km DC module has less than 7.5 dB loss. Fiber has an average dispersion that is 17 picosecond per nanometer kilometer of dispersion. A 10G channel can tolerate about 800 picosecond per nanometer of dispersion. It is the limitation of the 10G channel, what it can tolerate. This is 800 picosecond per nanometer. But 1 kilometer of fiber has 17 picosecond nanometer dispersion. So in this way, 500 kilometer development system can generate 8500 picosecond per nanometer of dispersion, and a 10G channel can tolerate 800 picosecond per nanometer. So it is so we have to use dispersion compensation model for running 10G channels. But in case of 2.5G channels, this is less sensitive by 16 times. So for 2.5G channels, dispersion is we have not we have no need to think about dispersion for 2.5G channels. For G.652 single mode fiber, this is good for TDM or SDH at 1310 nanometer, and this is also okay for 1550 nanometer. But in case of DWDM, we have to use dispersion compensation model for 10G or more bandwidth channels. If we use 36 km single mode fiber, we have to use 7.6 km DC fiber to compensate. And if we use 72 km single mode fiber, we have to use 15 km DC fiber to compensate. And in the same way, if we use 120 km single mode fiber, we have to use 25 km DC fiber to compensate. Coherent technology is working on super channels, that is terabyte channels, 100 Gbps channels, 200 Gbps channels, and here they use digital signal processing technique, and it clears all dispersion issues. PMD polarization mode dispersion also limits bandwidth for 10G or more bandwidth channels, but it actually limits the more 40G or 100G channels. It is not very effective in case of 10G or less bandwidth channels. Polarization mode dispersion is happening due to disturbance of electromagnetic field imbalance of light pulses because of very thin core fiber. And polarization mode dispersion, actually the optical pulse tends to broaden as it travels down the fiber. This is much weaker phenomena than chromatic dispersion and is effective for 40G, 100G or more bandwidth channels. Chromatic dispersion actually happens due to different wavelengths travel at different speed of light. So after some distance in fiber, optical pulse tends to be broadened. There are different types of dispersion: model, material, waveguide, and polarization mode dispersion. Chromatic dispersion, also called intramodal dispersion. There are two kinds of dispersion which affects impacts the DWM signals. These are chromatic and polarization mode dispersions. Thank you.